This is Marques Brownlee, a well-known technology reviewer on YouTube. He has made many videos testing and experiencing Tesla vehicles. And when Elon Musk announced that the Tesla CYBERCAB would be priced at $30,000, Brownlee said Tesla wouldn't be able to do it. There was no way Elon Musk could pull that off. He even said that if Tesla managed to produce the CYBERCAB at a $30,000 price point before 2027, he would shave his head on camera. So, right after Tesla announced that the first CYBERCAB had been produced on the Giga Texas production line, a meme image of Marques Brownlee with a shaved head immediately went viral on X. The reality is that Elon Musk is more serious than ever about the Tesla CYBERCAB and the robotaxi network. The Tesla CEO has repeatedly emphasized that CYBERCAB production will begin in April, and the fact that the first CYBERCAB has already rolled off the production line at Giga Texas proves that the company has completed a manufacturing line known as the unboxed process, built specifically to produce the CYBERCAB. So how can the CYBERCAB reach a $30,000 price point, and how will Tesla be able to manufacture CYBERCAB such a rapid pace a few days earlier? Tesla announced that it had produced the first CYBERCAB off the production line at the Gigafactory Texas plant. This came as a bit of a surprise, since it's only February, while Elon Musk has repeatedly confirmed that the vehicle would enter production in April. More recently, Elon once again emphasized on X that CYBERCAB, which has no pedals or steering wheel, starts production in April. If you follow Tesla, are a Tesla fan, or are interested in autonomous driving technology, this is clearly very positive news. It's a good sign because it essentially provides a concrete link leading to the milestone of production starting. According to expectations, this could be the first production unit revealed to show that Tesla has truly completed the CYBERCAB production line. After months of speculation that the company might not be able to keep up with the timeline due to the unboxed process requiring more time to set up than traditional vehicle production lines. We know that Tesla has already built quite a few CYBERCABs. We've seen more than 20 of them and possibly over 30 in real life. But as far as we understand, most of these CYBERCABs may have been hand-built or produced using only certain parts of the production system based on the unboxed process. As Elon Musk has repeatedly revealed, the unboxed process completely rethinks traditional manufacturing, which is normally based on a single main body moving along a conveyor line. Instead, the CYBERCAB's components are fully assembled as separate modules and then joined together only once at the final stage. Many people have argued that this process is extremely complex, requiring tight synchronization between robotic arms and factory management software systems. That led to predictions of prolonged delays similar to the Model 3 production hell from years ago. However, this first CYBERCAB unit is strong evidence that Tesla has actually made far better progress than we expected. As you know, Tesla is usually later than the timelines it publicly announces. This suggests that they have already set up production stations inside the factory. We don't necessarily think it needs to be called a traditional assembly line. Instead, you can think of them as unboxed production stations within the plant. They turn them on, and they produce doors, body panels, and everything else that Tesla manufactures in-house. The material system pulls components from suppliers, delivers them to the correct locations, packages them properly, and the entire vehicle goes through a complete assembly process. Now, after completing this first vehicle, what will Tesla do next? This car may never see the light of day. It could be disassembled immediately, taken completely apart so engineers can inspect adhesive bonds, welds, mechanical fastening points, fitment, surface finish, and every tolerance-critical detail. Alternatively, the vehicle could be sent into durability testing. It could serve a variety of internal purposes, but one thing is certain: it will not be delivered to a customer. From now until April, Tesla will gradually ramp up the speed of its machinery. Of course, with a completely new system like the unboxed process, there will be plenty of gaps and early-stage errors. The CYBERCAB will inevitably run into some production issues, and Tesla's engineers will implement corrective actions. You need to understand that start of production doesn't mean the factory lights are off, then suddenly switched on with an announcement that production has begun. It's not that simple. The initial production rate of the CYBERCAB will definitely be very slow, because the system has not yet been optimized or refined the way the Tesla Model 3 or Model Y lines have been. But once you've passed those early milestones, once reliability has been validated, the hardware is stable. Electrical and electromechanical functions are working properly. Issues have been resolved, parts fit together correctly, and there are no abnormal noises. That is when you truly enter the production phase. In manufacturing, the moment you start assembling and adding value to a product, risk and responsibility increase very quickly. That's why you have to start slow and then ramp up. Even things like how wiring is routed inside the vehicle. Details we never see are brand new. When so many new elements are introduced at the same time, you have to keep the speed low but production steady. At low speeds, you can detect new problems and fix them faster, while affecting fewer vehicles. That's exactly why Elon Musk has said the early phase will be extremely slow, following an S-curve. However, once the CYBERCAB production system is optimized, the line will run so fast that humans won't be able to get close to it. It will resemble a high-speed electronics manufacturing line, and Tesla could ultimately build a CYBERCAB in under 10 seconds. Beyond confirming that CYBERCAB production is on the right track, Elon Musk has once again hinted at the timeline for delivering the CYBERCAB to customers at a price under $30,000. When Tesla unveiled the CYBERCAB, a vehicle with no steering wheel, no pedals, designed purely for the robotaxi era, the biggest question was not whether it could drive itself. Instead, it was whether Tesla could truly sell the CYBERCAB for $30,000 before 2027. This is more than just a price point. It's the boundary between vision and reality, between technological promises and the real-world ability to manufacture at scale. Over the years, Elon Musk has repeatedly made bold claims about pricing and timelines, which has led many people to remain skeptical. But the CYBERCAB is a special case. It's not a conventional electric vehicle, nor is it an upgrade of the Model 3 or Model Y. The CYBERCAB is a product designed from the ground up, with the explicit goal of optimizing for cost, automation, and scale. The $30,000 price point is not a random number. It is an extremely important psychological threshold in the automotive industry. Below this level, a vehicle begins to reach the mass market, especially fleet operators, transportation companies, and service-based business models. With the CYBERCAB, Tesla is not aiming to sell cars to individual consumers in the traditional sense. Instead, the company is focused on the cost-per-mile equation. If a CYBERCAB costs around $30,000, requires no driver, and can operate nearly 24/7, the depreciation cost per trip drops dramatically. At that point, robotaxis are no longer just a technology demo. They become a business model that can directly compete with traditional taxis, as well as services like Uber or Lyft. In other words, $30,000 is the key that allows the CYBERCAB to cross the line from experimentation into the real market. But why do so many people doubt the 2027 timeline? Skepticism around the year 2027 is understandable. To sell a $30,000 CYBERCAB before then, Tesla must solve at least 4 major challenges at the same time. The first is fully autonomous driving, unsupervised FSD. A car with no steering wheel means there is no plan B. If the system is not safe enough or does not receive regulatory approval, the CYBERCAB simply cannot be sold. The second challenge is regulation. Every country and every U.S. state approaches autonomous vehicles differently. Even if the technology is ready, gaining approval for large-scale commercial operation is still a slow and risky process. The third challenge is manufacturing cost. Inflation, raw material prices, and global supply chains can all push costs higher. To hit the $30,000 target, Tesla must exercise extremely tight cost control across batteries, motors, body materials, and the entire assembly process. And finally, there is the issue of production ramp speed. A low-cost vehicle is only truly viable when produced at massive scale. If volumes are low, fixed costs per vehicle will destroy the entire cost model. So, why does Tesla still have a chance to pull this off? That said, the CYBERCAB is not a normal vehicle, and that is precisely where Tesla's advantage comes from. First of all, the CYBERCAB has significantly fewer components than a traditional car. According to reports from Tesla's engineering team, especially the lead engineer on the CYBERCAB project, the vehicle has about 60% fewer structural components than the Model Y. More specifically, the CYBERCAB's body structure consists of roughly 80 parts, compared to around 200 parts for the Model Y. No steering wheel, no pedals, no complex dashboard, and no extensive personalization options. All of this directly helps reduce costs. Second, as we explained earlier, Tesla is pursuing the unboxed manufacturing model, a completely new approach in the automotive industry. Instead of assembling vehicles along a linear production line, large modules are built in parallel and then married together at the final stage. Yeah, if this model works as expected at scale, labor costs, assembly time, and factory footprint could all be reduced in ways that few people anticipated. In addition, the CYBERCAB has been confirmed to use Tesla's in-house 4680 battery cells, which is another major advantage. Tesla has recently announced progress in optimizing the dry electrode process for these cells, significantly lowering battery costs. Third, the CYBERCAB does not need to be as perfect as a consumer vehicle sold to individuals from day one. In the early phase, the CYBERCAB's largest customer is likely to be Tesla itself. through its internal robotaxi fleet. This allows Tesla to tolerate slightly higher risk, iterate and fix issues gradually during real-world operation, rather than having to meet a perfect consumer standard on day one. If Tesla manages to sell even a limited number of cybercabs at a $30,000 price point before 2027, it would set a historic precedent. It would prove that autonomous vehicles are no longer the exclusive domain of expensive pilot programs, but can become a genuinely commercial product. On the other hand, if Tesla fails to reach this milestone, the company will face a new wave of skepticism. Even in that scenario, however, the Cybercab could still succeed as an internal robotaxi vehicle, just not yet at a truly breakthrough price. That said, to be fair, behind these symbolic milestones, Tesla's robotaxi effort is still facing a series of technical, legal, and public trust challenges that the company cannot avoid. It's undeniable that Tesla is moving fast, while many competitors remain focused on limited pilot programs. Tesla has already put its robotaxi into real-world operation in Austin, accumulating hundreds of thousands of test miles in a relatively short period of time. At the same time, the company is pushing forward with the Cybercab, a vehicle designed specifically for robotaxi use with the goal of mass production on a very ambitious timeline. From a strategic perspective, this speed gives Tesla a crucial advantage. Data. Every real-world mile driven generates valuable information for training and refining the autonomous driving system. However, moving fast also means Tesla is forced to confront problems earlier, issues that other companies can afford to delay by staying within controlled testing environments. And the data so far suggests that Tesla's robotaxi has not yet reached the level of safety that many initially expected, according to filings submitted to the National Highway Traffic Safety Administration. Tesla has reported a total of 14 crashes involving its robotaxi program since the program began, based on an operating distance of roughly 800,000 miles. This suggests an average of one crash every 57,000 miles. This figure becomes concerning when compared with safety data previously published by Tesla itself, which claims that an average American driver experiences a minor collision only once every 229,000 miles. This gap raises a fundamental question: is Tesla's robotaxi currently safer or less safe than a human driver? When the stated goal of autonomous vehicles is to eliminate human error, a higher crash rate than that of ordinary drivers is clearly a paradox that has yet to be convincingly explained. The contrast becomes even sharper when Tesla is compared with Waymo, Alphabet's self-driving unit. Waymo has logged more than 127 million fully driverless miles, with an average of one crash every 98,000 miles. While this figure is still not ideal, it is nevertheless significantly better than Tesla's robotaxi performance. More importantly, Waymo has taken a cautious approach to deployment: tightly geofenced operating areas, transparent approval processes, and vehicles that operate without anyone in the cabin, while also not relying on implicit backup measures. By contrast, Tesla has faced questions about whether it uses human-driven vehicles following behind to support robotaxi operations, even while claiming that the service is deployed without in-vehicle supervision. This blurs the line between fully autonomous and autonomy with assistance, a distinction that is critical in safety evaluations. One of the biggest obstacles Tesla now faces is not hardware or software, but trust. When reports submitted to the NHTSA contain heavily redacted details, the public and analysts are left to judge performance using only aggregate numbers. This means that every crash, no matter how minor, quickly becomes a focal point of controversy. Okay, in the autonomous vehicle space, transparency is not just a regulatory requirement, it is a prerequisite for social acceptance. Waymo, Cruise, and other competitors typically disclose more detail about operating domains, incident types, and accident contexts. Tesla, with its move fast and fix later philosophy, is putting itself in a difficult position as deployment speed outpaces the building of public confidence. And even if the technology reaches an acceptable level, Tesla's robotaxi still has to navigate a complex legal maze. Each U.S. state and each city takes a different approach to autonomous vehicles. Deployment in Austin does not mean Tesla can rapidly expand elsewhere. The current accident statistics, while not catastrophic, could still give regulators reason to tighten approval processes going forward. This becomes especially important in the context of Tesla's goal to commercialize the Cybercab at a price of around $30,000 before 2027, a product that is inexpensive and quick to manufacture, but constrained by legal and regulatory barriers, will struggle to achieve the economic scale Tesla is aiming for. Regardless of how we feel about it, the Cybercab is Tesla's next vehicle, The first production unit has already been completed, and the idea that it could be sold to customers later this year may still be a bit optimistic. Given that the vehicle has no steering wheel or pedals, it would be strange if it required a human just to plug it in. In fact, the CYBERCAB is expected to use wireless charging technology, and Tesla has recently received approval for this approach. Over the past few months, several videos posted on X have sparked controversy by showing the CYBERCAB being charged in the conventional way, pulling up to a charging station and plugging in, similar to a Model Y or Model 3. This understandably caused debate, since Tesla had previously stated that the CYBERCAB would recharge itself via wireless charging, as shown in company demonstration videos. In practice, however, the CYBERCAB can charge in two ways: traditional plug-in charging like other Tesla vehicles, or wireless charging. Before wireless charging was fully approved, the vehicle would primarily rely on conventional plug-in charging. The wireless charging system the CYBERCAB is expected to use is based on ultra-wideband radio technology, which requires special authorization from the Federal Communications Commission to operate as fixed outdoor infrastructure. The good news is that Tesla has now received that approval. When the vehicle approaches the ground pad, the UWB transceivers will operate to track the position of the vehicle to determine when the optimal position has been achieved over the pad before enabling wireless power charging. Ultimately, we believe the CYBERCAB is more than just a new Tesla model. It is the clearest statement yet of the company's long-term ambition, a future where humans no longer need to drive. The concept of a $30,000 robotaxi with no steering wheel and no pedals sounds both captivating and far-fetched. It is precisely this contradiction that makes the CYBERCAB such a polarizing topic. To Elon Musk, this is the inevitable next step for modern transportation. But for much of the public, the question remains, is Tesla actually ready? The reality is that the CYBERCAB still sits on the fence between vision and reality. Full self-driving technology still needs time to prove its safety across every possible scenario. Legal regulations, specifically requirements regarding steering wheels, have yet to catch up with the pace of technological innovation. Even if Tesla can mass-produce the CYBERCAB, getting them legally onto public roads remains a long and complex journey. Nevertheless, there is no denying that Tesla is posing a question the entire industry is now forced to answer: to what extent are we willing to embrace autonomous transit? The CYBERCAB might not be fully ready this year, but it has forced the world to rethink the future of mobility. Much like electric vehicles a decade ago, what was once met with skepticism has now become the new standard. So what do you think? Is the CYBERCAB a premature move, or a vision ahead of its time? Would you be willing to hop into a car with no steering wheel and hand full control over to a machine? Let us know your opinions, because this future, sooner or later, will likely involve all of us.